Now on Nova. Take a thrill ride into a world stranger than science fiction, where you play the game by breaking some rules, where a new view of the universe pushes you beyond the limits of your wildest imagination. This is the world of string theory, a way of describing every force and all matter, from an atom to Earth to the end of the galaxies, from the birth of time to its final tick, in a single theory, a theory of everything. Our guide to this brave new world is Brian Greene, the best-selling author and physicist.
And no matter how many times I come here, I never seem to get used to it.
Can he help us solve the greatest puzzle of modern physics? That our understanding of the universe is based on two sets of laws that don't agree. Resolving that contradiction eluded even Einstein, who made it his final quest. After decades, we may finally be on the verge of a breakthrough. The solution is strings. Tiny bits of energy vibrating like the strings on a cello. A cosmic symphony at the heart of all reality. But it comes at a price. Parallel universes and 11 dimensions, most of which you've never seen.
We really may live in a universe with more dimensions than meet the eye.
People who've said that there are extra dimensions of space have been labeled crackpots or people who are bananas.
A mirage of science and mathematics? Or the ultimate theory of everything?
If string theory fails to provide a testable prediction, then nobody should believe it.
Is that a theory of physics or a philosophy?
One thing that is certain is that string theory is already showing us that the universe may be a lot stranger than any of us ever imagined.
Coming up tonight, the undeniable pull of strings.
The atmosphere was electric.
String theory goes through a revolution of its own.
5 different string theories.
And reveals the new shape of things to come.
Perhaps we live on a 3-dimensional membrane.
Our universe might be like a slice of bread.
We're trapped on just a tiny slice of the higher dimensional universe.
That's actually a problem.
Watch The Elegant Universe right now.
Imagine that we were able to control space or control time. The kinds of things that we'd be able to do would be amazing. I might be able to go from here to here to here to here and over to here in only an instant. Now, we all think that this kind of trip would be impossible, and it probably is. But in the last few years, our ideas about the true nature of space and time have been going through some changes, and things that used to seem like science fiction are looking not so far-fetched. It's all thanks to a revolution in physics called string theory, which is offering a whole new perspective on the inner workings of the universe.
String theory holds out the promise that we can really understand questions of why the universe is the way it is at the most fundamental level.
String theory is really the Wild West of physics.
This is an area of theoretical physics which is so radically different from anything that's been before.
This radical new theory starts with a simple premise that everything in the universe, the Earth, these buildings, even forces like gravity and electricity, are made up of incredibly tiny, vibrating strands of energy called strings. And small as they are, strings are changing everything we thought we knew about the universe, especially our ideas about the nature of space. To see how, let's first shrink all of space to a more manageable size. Imagine that the whole universe consisted of nothing more than my hometown, Manhattan. So now, just one borough of New York City makes up the entire fabric of space. And just for kicks, let's also imagine that I'm the CEO of a large corporation with offices on Wall Street. Because time is money, I need to find the quickest route from my apartment here in Upper Manhattan to my offices in Lower Manhattan. Now, we all know that the shortest distance between 2 points is a straight line, but even if there's no traffic, a bit of a stretch, even in our imaginary Manhattan, it'll still take us some amount of time to get there. By going faster and faster, we can reduce the travel time, but because nothing can go faster than the speed of light, there's a definite limit to how much time we can cut from our journey. This Manhattan universe fits with an old classical vision of space. Basically, a flat grid that's static and unchanging. But when Albert Einstein looked at the fabric of space, he saw something completely different. He said that space wasn't static. It could warp and stretch. And there could even be unusual structures of space, called wormholes. A wormhole is a bridge or a tunnel that can link distant regions of space. In effect, a cosmic shortcut. In this kind of universe, my commute would be a New Yorker's dream. But there's a hitch. To create a wormhole, you've got to rip or tear a hole in the fabric of space. But can the fabric of space really rip? Can this first step toward forming a wormhole actually happen? Well, you can't answer these questions on an empty stomach. Turns out that by looking at my breakfast, coffee and a donut, we can get a pretty good sense of what string theory says about whether the fabric of space can tear. Imagine that space is shaped like this donut. You might think that it would be very different from a region of space shaped like this coffee cup. But there's a precise sense in which the shape of the donut and the coffee cup are actually the same, just a little disguised. You see, they both have one hole. In the donut, it's in the middle, and in the coffee cup, it's in the handle. That means we can change the donut into the shape of a coffee cup and back again without having to rip or tear the dough at all. Okay, but suppose you want to change the shape of this donut into a very different shape, a shape with no holes. The only way to do that is to tear the donut like this, and then reshape it. Unfortunately, according to Einstein's laws, this is impossible. They say that space can stretch and warp, but it cannot rip. Wormholes might exist somewhere fully formed, but you could not rip space to create a new one over Manhattan or anywhere else. In other words, I can't take a wormhole to work. But now, string theory is giving us a whole new perspective on space, and it's showing us that Einstein wasn't always right. To see how, let's take a much closer look at the spatial fabric. If we could shrink down to about 1/millionth of a billionth of our normal size, we'd enter the world of quantum mechanics.